All right, so I think this is recording. Let's take a look at these three problems. They are quadratic equations, and we want to solve these quadratic equations. But we can't just jump in there and solve them any way we want to. The directions specifically say to use the technique of completing the square. So if you factor this, or if you use the quadratic formula, you are going to receive very, very little points, maybe no points, very little partial credit. I do give partial credit, but you have to be partially correct. If you do not follow the directions, then that's not correct at all. So there's no partial about it. So you must learn this technique. You must solve this by completing the square. So in problem number 13, and actually in all of these problems, we want it to look like 15. We want to write this in standard form because our leading coefficients are 1. So it's important that we have a 1 in front of that x squared when we're doing completing the square. Okay, so I'm going to add 4 to each side, and I'm going to start with this. Now, I'm actually going to now add 7 to each side because this value for C is not what I want in order to complete the square. I need to take half of -10 and then square it. So I'm going to move this term out of my way for just a moment. And I know from my previous problems to take half of this value of C that I want to take B over 2 and square it. Okay, so B is -10, and I'm going to take half of -10, which is -5. And -5 squared is 25. And now this time I have an equation. So to balance this equation, I'm going to have to add 25 over here to the other side. All right. I don't need this anymore, so I'm just going to erase it out of our way. On the left-hand side, I can factor this now. That was the whole purpose of that. And it's very easy to factor because it factors into a perfect square. What's half of -10? -5. And now on the right-hand side, 7 plus 25 is 32. And I can come in and take the square root of both sides. Now, there's a step that I always include that I think many people don't put enough emphasis on it. When you take the square root of a variable, this is actually the absolute value of x minus 5 because this symbol, this radical symbol, means the positive square root. So we don't know if the value of x could be such that x minus 5 is a negative number. Well, I need that to be positive if it's the result of taking the principal square root. Now over here, I'm just going to leave this as the square root of 32 for right now. Well, let's rewrite 32 as 16 times 2. All right, so I know how to solve absolute value equations. I have x minus 5 is equal to negative. Well, I can take the square root of 16. So it's either equal to -4 radical 2 or x minus 5 is equal to +4 radical 2. So I have two solutions, 5 minus 4 radical 2 and 5 plus 4 radical 2. Now, I don't expect you to do it the exact same way that I do it in my solution. I do expect the completing the square step, but if you want to go straight to plus or minus 4 radical 2, I don't have a problem with that. So I'll do that in the I won't emphasize that step here this next problem. I'll go straight from taking the square root of each side to what my answers are. All right, so let's take a look here at number 14. we have 1x, we have 1x squared plus 6x. And, I know that if I take half of 6, that's 3, and 3 squared is 9, that negative 18 is not 9. So I'm going to add 18 to each side of this equation. And so that the negative 18 will cancel, and negative 9 plus 18 is a positive 9. And now I'm going to come in and figure out what this value of c has to be, and I already know how to do that. It's going to be b over 2 squared. And here b is an even number, so that's nice. It's pretty easy to take half of 6, that's 3, and 3 squared is 9. So I'm going to add 9 to the left-hand side of this equation. So therefore, I'm going to add 9 to the right-hand side of this equation to balance it. I didn't have to do that step up in the earlier problems because they weren't equations, they were expressions. But with equations, I have to balance the equations. All right, so on the left-hand side, I can factor this very, very easily. I can factor this, well, half of 6 is 3. The x plus 3 squared, which is equal to 18. So what you've always done before when you come in and take the square root, you've always came in and been told, hey, put a plus or minus symbol there. And that is correct because but the justification for that plus or minus is coming here in this step of taking of when you take the absolute value of a variable, getting that, or excuse me, when you take the square root of a variable, getting that absolute value. But I'm just going to look at this as saying that when I take the square root of x plus 3 squared, that the square goes away. And over here, I know that the 18 can be split into 9 times 2. And I know what the square root of 9 is. It's 3, and I can't simplify the square root of 2. So I get my final answer to be negative 3 plus or minus 3 radical 2. And that's how most of the time you're going to see this done. And I don't have a problem with you doing it that way. I just feel bad for students that think that plus or minus goes there because they think that when you take the square root of 18, that they do things like the square root of 4 is plus or minus 2. And the square roots of 4 are plus or minus 2, but this symbol is telling you to take the positive square root of 4, which is simply 2. So this is wrong to do like that, and it's correct to say that. So why do you put the plus or minus symbol in here? If the square root of 18 is a positive number, it's because you had a variable on the left-hand side, and when you took the square root of that variable, it introduced an absolute value equation, and that absolute value equation introduced our plus or minus into our solution set. All right, so let's come over and take a look at this number 15. Let's do it in a similar way. X squared minus 7x. Well, half of negative 7 is just negative 7 halves. I'm going to add 8 to each side, and now I need to figure out what c has to be for this to be a perfect square. And I know the formula. I know that I want c to be half of b over 2 squared. Well, b is negative 7. And negative 7 over 2 squared, I'm just going to write that as positive 49 over 4. So I'm going to write plus 49 over 4 here. And if I add that to the left-hand side, to balance the equation, I have to add that to the right-hand side. You have to ask yourself, well, why? Why did we do that? We did that so that on the left-hand side, it will be very easy to factor this. This factors to x minus, well, half of 7. Now, over here, I'm going to have to get a common denominator. I'm going to rewrite the number 8 as 32 over 4. And your calculator, these scientific calculators, can do all that for you. So now that I have a common denominator, I can add these two things together and get 81. And when I go to take the square root of both sides, if you don't want to include this extra step of writing absolute value, you can just put plus or minus in there, and when you take the square root of a fraction, you can take the square root of numerator and the square root of denominator separately. The square root of 81 is 9, and the square root of 4 is 2. All right, so we can get this x by itself by adding 7/2 to each side. So we have 7/2 plus or minus 9 over 2. Well, if you subtract 7 minus 9 is a negative 2, and negative 2 divided by positive 2 is negative 1. If you add 7 plus 9, you get 16, and half of 16 is 8. So this is not just our final answer. Yes, this is the solution set to this equation, but what you're really being graded on is all of these steps to get there. And so you can't factor it, you can't use the quadratic formula, you have to do it by this technique that is completing the square. Now, if you want to leave out the absolute value, that's fine. I don't have a problem with that. So I hope this helps. I will talk to you later. Bye.